Aloha, Richard Halverson here, and this is ITS128. And today is Tuesday, November 24th, a couple days before Thanksgiving. Let me share my screen. And so we are let me make this big. We are in this week right here on Tuesday. And so today I'm going to try to get as far as I can into chapter 8. We started chapter 8 last week, but I have earlier today I recorded how to do all of the labs. So, and it just finished processing. So I'm going to put this video right now up next. And then right after that, I'll put the video that covers all these up. And we'll see how far we get today in chapter 8. And we might get done, or we might have to finish a little bit of chapter 8 next week. But we'll be able to get right into chapter 9 next week. So so chapter 8, we're doing lists and dictionaries. And I think we got as far as, if we click on the resources here and see where these are the class videos. And it says here that the last video took us up to section 8.5. Okay. So I'm going to assume I finished 8.5. And so let's go to 8.5 and remember what that was. Oh, list nesting. Oh, yeah. So all lists, we make lists, but we can have lists within lists. We can have, a list, a list, but you can think of it like a table where each row is like the outer element of the list, but then inside each row there's an actual list inside each row too. So that's like a double list, a multi-dimensional list, or a two-dimensional list in this case. And so here the first row would contain this list and the second row would contain this list. So so in this case we have my list, and the first index is the row, and so the first one. So if this is my list, my list of 0 is this, and my list of 1 is this. Can we see this? See, just like that, and 0, 0 is the first one anyway. So that's a list within lists. Here we have a 3-row list, a 3-row 2-column list. So anyway, so that was the last thing we did last week. Okay, so list slicing now. This is 8.6. This is where we just take portions. We use fancier indexing, and we put a range in there. Instead of just an index, instead of just indicating 1, we put a range. It's two integers with a colon in the middle, and so that's a slice. So that's what slice notation is. So if we have a list, let's see, here's a list, Boston Bruins. There's a 0, a 1, and a 2. And if we want the 0 in the first element, we go like this. Remember, whenever we do this notation with a colon in the middle, an integer and a colon and an integer, it's always up to but not including the upper integer. Excuse me. All right, so let's see what the comment is. Okay, great. You're welcome. Here, for example, so this would be 0 and 1, but not 2. And this is 0, 1, 2, and that's this. And then, so here it's 1 and 2, not 3. Okay, so it includes the lower and, you know, okay, so you know that from strings. Okay, so that's slicing, list slicing. There's a stride in there. If you want to go all the way up to the top, you don't have to put the upper one. If you want to start out right way at the beginning, you don't have to put the lower one. And getting the whole list itself is you can just put a colon in there, and you mean the whole range. Match the expression on the left with the resulting list on the right. 5, 8, 13, 21, 34. 0, 1, 2, 3, 4 to the end. This one. Okay. So anyway, you can do that. What is this? My list of. Ooh. It's obviously going to be nothing because the lower range is higher than the upper range, and so there's not going to be anything in there. Oh, since there's not 20 in there, that must be this one. Okay, anyway, you can finish that. Challenge activity. Okay, so in this one, we wanted 0 through 4, 0, 1, 2, 3. That's it, okay. Put 0 to 2, so that'd be these two. Oh, what? Oh, I got to print. Oh, yeah, sure. Right. All right. All right. 0, 1, 2. Hey, well, what do you know? Okay, anyway, so here's a stride of 2. So that would just be 13, skip 14, and put 15, and skip 16 and put 17. And that's probably it. Is that right? Yeah, that's right. Okay. So anyway, you can go through those. That's stride. And then loops modifying lists. When am I going to get to Oh, I missed a challenge activity. Let me go back to 8. I don't recall doing this challenge activity yesterday. So I'm going to go back to, okay, this is 8.7, right? Oh, yeah, this is 8.7. I just did 8.6. There was a challenge activity in 8.5 that I didn't do. Let me go back and look at that. List nesting. It must have been. Here, this one. Okay. I don't recall doing this one. So I'll do it now. Okay, so we're going to input, print a two-dimensional list that by row and then column and use nested loops. And oh, it's this. This is how you input it. And you want it to do you want this to be the first row, comma, second row, comma, third row. And when you print it out, you want to put vertical bars there. Okay. Well, let me copy this. Copy. And I'm going to paste it over here. Okay, so, oh, there I split it up. Okay, so now I just got to print it out, huh? Okay, so I read in this whole line like this. Yeah, right. I read in the line, and then I split on the comma. So each one of these is one line. Okay, so there's going to be 3 lines. This is the 0th one, this is the 1, and this is the 2. And so then I split that line into numbers, but those numbers are still strings, so I need to make them integers. So this makes a list of integers for that row. And then okay. So the outside one takes, for each line in lines, it does this. It turns it into for each line in lines, it turns it into a list. And it's a list where it takes the line, splits it by the space, and we can probably do this a different way. We can do this. It might be easier if we did. First, let's split the line. This splits it in the lines, and then for each for line in lines, mult table. Never mind. I don't need to do that. All right, so we have the table here, and now we just need to print out for each row, for each row in mult table. For each row, we want to print out. It's an array. It's a list. So for each element in row, we want to. We're doing indexes. All right, let's do it. Let's do this in index way. Index in range of row. Range of length of row. Okay, so that way we're referring to each one by index, because if it is the first, okay, so see the problem is we only want to print this vertical bar after 0 and after 1, but not after 2. Okay, so so for 0, I know if it's 0, okay, well, if it's 0, we'll just print the number. If okay, no, yeah, we'll just print the number. If I equals 0, then we want to just print row of I, end equals space. I think that's what I want to do. Else, so now I is equal to 1 or 2. I want to print a vertical bar. Vertical bar. And then a space after that. No, I'm going to do this space here. And then a row 1, row I. All right, it's different than what the solution is, but that's fine. All right, so all right, let's run this and see what it looks like. Oh, I got to input some. Oh, I got to input this. Copy. Paste. Why? Because I needed to do end equals this. Does that work? And then I need to do print. Is there some kind of... No, I'll just do that. See what that does. Oh. Oh, wait a minute. There. There we go. All right. That took a long time. Okay, so that's that challenge activity. So this thing, so this creates, the outside one creates different, you can think of it as creating the different rows, and inside each row, this thing creates a list, and this list sort of represents the columns within each row. So anyway, all right, let's go back to 8.7. All right, so changing the elements inside of a list, yeah, you can change. Modifying a list during iteration. I see no reason why you can't do that. Goes through and this, you index it, and this is how you modify it. Converting negative values to 0. Correct way to modify the list, incorrect way. List is not modified. Okay, now why would that be? Okay, so we input some numbers, we split them into tokens, then we create a new list, blank list, and we append each token into this list of numbers after we integerize each token. And then we print each position and numbers. So I guess you can do it this way. This prints a blank line, and then for each position and value, this is going to be the index, and this is going to be the value from the index when we enumerate these numbers. So the position is going to be here, and then we print a colon, and this is the value. We print the position, then the value. So it's the index, and the value. And then that prints them out, and then this thing is going to actually change the position, whereas this no, this wouldn't work, obviously. All right, well, anyway. Obviously, if you're going to change an element in a list, you got to do it this way. You don't loop through all of them and then do it that way. That only changes this variable. It doesn't actually change the element of the list, even though this loops through the elements of the list. And this is the actual value. This would be the value of the element. This changes the variable value. That does not change the element itself, whereas this does. All right. Yes, incorrect way. Correct way. Okay, what is this challenge? Okay, this one here is user values to that. Okay. Sure, okay. Uh, 148. For each position in the range of the length of this, the length is 3, so 0, 1, and 2. Looks like we're summing them up. So sum of this, summed with this, summed with this would be 17. 2 plus 6 is 8, plus 9 is 17. And then we're going to print it out, it looks like. Starts at 0, okay. 17, print. All right. What this is going to do is if it's going to print all of the ones where the value is less than 0. So it's going to print the -1, and it's going to print the -7, but it's not going to print the 3 and the 5. And it's going to print them one right after the, there's going to be a space in between. So -1, oops, -7. All right. So anyway, you can continue. Okay, yeah, you can't iterate through a list and try to add or remove it because you're iterating through it and it's going to mess up the iteration. All right. So this, in this example here, list modification, what are we doing? We are for every one of these, we want to remove okay, for this list, we want to go through this. If an element is in this list, we want to remove it. I see. All right. Okay, so this compares, if we go through every value in here, and for each one, we want to see if it's in this list, and if it is in this list, we want to remove it. And so this is one way of iterating through it, and this is another way of iterating through it, where in this way, you refer to the list by its name like this, And here you refer to the list by using this colon, colon index notation. And then we're supposed to figure out which one's better. Okay, let me start this. So in this one, it misses the 15 because because as it increments through. Okay, now with this one, if this one, with this one, val is a copy of nums1 is created. That's down here. And then as val loops through, it makes sure that it gets everything because in this one, it ends up missing one because once it's pulled out, it actually messes up the indexing. And this is looping through by the index of the one we're manipulating. And this one is looping through a copy of the original list. So this is still going to get every one of them, whereas this one is not. So that's something to. So if you want to do that, it's probably don't want to do that very often. But if you do, make sure that the outside loop, you're indexing a copy of the list if you're manipulating the list, a copy of the original list. All right. Let's see, for this one, modify the program from above using slice notation to iterate over a copy of the list. Okay, let's try. Let's see what this looks like. 10, 15, and 5, 10, 15. 5, 10, 15. Okay. I didn't look at this before. I didn't look at this before today, so I'm not sure what we're supposed to be doing here. Okay, we input a set of numbers, and then we split them, and these are tokens. So the tokens, and then for each one we append. For each token, this is the position. 1, 2 is 10 and 15. Why? Oh, no, this is right. Oh, this is right. 0, 5, 1 is 10 and 15. This is the second set. and we delete the, is the first one, so we are looping, then a second set of numbers, and then we loop through, this prints out the second set of numbers. Then we, for each value in nums1, if that's in there, then we delete it. Okay, so what we want, I see. Okay, missed one. Okay, got it. Okay, so I need to do, is that what I need to do? Yeah, that's right. Okay, all right. So I just had to, based on this, I had to fix it. Okay, anyway, great, fantastic. List comprehensions. Okay, what these are is this is where, you know, you have a list, and let's say you're reading a list of strings. You're reading a list of strings and you want to change them to integers. This is how you do it. Okay, so use what's called list comprehension. And so comprehension, look, okay, here's, so let's say we have this is a dumb list. This is a dumb example. But let's say you got a list here, and you want to make a new list, and you want the new list to be where you take every element of the first list and add 5 to it. Okay, so instead of 10, 20, 30, it becomes 15, 25, 35. Okay, well, a way to do that would be to loop through every number in the list, and every number in the list add 5 to it. So I plus 5 for every I in my list. And that is going to be a new list. You see, you got these things here. So that's a new list. And that's the name of it. So that's how that works. Here's an example of subtracting 10 from every element in the list. So this becomes 40, this becomes 13, and this becomes minus 14, I guess. Oh, yeah, right. Exactly. Great. Okay. So convert, these are examples, I guess. Here you're going to convert every element to a string. Okay, now here you have a bunch of numbers, and you go through the range, and okay, this is one way to do it. And this is equivalent list comprehension. So basically is you're, in these examples, you're doing the list manually, and here you're using this fancy list comprehension notation. Boy, that can't even use help. Well, anyway. So this is useful. This is most useful if you're going to read in a bunch of integers on a line, and you want to convert those to a list of actual numbers. I don't quite understand your question. Is the I element only for index or iterable? It can be anything. It's how it's used. So here it's just using a variable. It's just a variable name, and it can be anything. It can be it can be a word. So that's, I hope that answers your question. So this is,
Thank you.
yeah, okay. By by iterable, you're talking about a list, something that you can iterate through. And it doesn't need to be a list, but something that you can iterate through. And here, I is just like one of them. And as you iterate through, the one that you're talking about is, can be referenced as I. And again, these are all conventions. You'll notice in the video I made earlier today on the labs, I get kind of mental block and I can't think of names, and I just make up some names. But anyway, so that's kind of the point there. Okay, so comprehensions are very handy, and you'll see them used in let's see, let's do this challenge activity here. You have a list, and you're making a new list, and you're doing it by taking every number in the iterable in the my list, and you're adding 4 to it. So you're adding 4 to this, and you get that. Okay, so let's start and see what happens. Okay, now you're multiplying it by 5. Okay, so the first one is going to be -1 times 5 is -5. And then I guess, oh no, it's just going to be a list. I think do I got to do this? I think I got to do that. -5, comma, 0, comma, 5, comma, 10. Is that right? Yes. Here you're saying the new list. Oh, this is a fancy one. Okay. It's a number for every number in my list where might be a better, but it's if the number is less than 2. So is less than -2. So -3 works. Start with that. -3 works. -2 does not work. None of them work. It looks like this is the only thing. Yeah, that's it. Okay. The next one is number plus 4 for each number in my list if number is less than 1. So we're only talking about these two, because those are the only two that are less than 1, and we're going to add 4 to them. So -3 plus 4 is 1, and -2 plus 4 is 2, and that's it. I forgot to put the return. Oh, is it letting me fix it? Is it the same? Yeah, it's the same. All right, anyway, so what's next? Sorting lists. Okay, there's the sort method. And all you got to do is put .sort, parentheses, end parentheses, after the list, and it automatically sorts it. So it's like a statement. Okay, it's not an expression. It's a statement. It does something. I guess. Is that right? Is it always that way? Yes, it is. It's always sitting there all by itself. So it's not like you got something equals books.sort. It's just the sort. All right, so that's pretty cool. Sorts it all by itself. Lists do that. Okay. Here it's example where you read in a bunch of books, and then you sort them, and then you print them out. Sort method modifies a list in place. That's true. The output of the following is 1375. No, it'd be 5, 7, 13. Yeah. Okay, sorted. Yes, that sorted is that's an expression. Sorted is an expression. So you can print an expression. You can't print a statement. Okay, so we have a list inside here, and we sort the list, and it's going to end up being -5, 2, 5. It's going to be the smallest one is -5, the next one is 2, and the third one is 5. So this is wrong. This is not going to print that way because it should print -5, 2, 5. So this is false. Yes. All right. Using a key argument. Okay, so this is if you have a key string. So this is a way of modifying the key a little bit. So it sorts on a key, and in a list, there's only the key is just the element itself. In a dictionary, you've got the key is separate from the value, but in a list, the key and the value are kind of the same thing. And so this like modifies the key, and it means consider just lowercase. I mean, make the key lowercase and then sort based on that. The key specifies a function to be applied to the element prior to it being compared. So here it says first make it lowercase, and then then sort it. Okay, and here you're taking care of if somebody types in lowercase names versus uppercase. Key max. Okay, so here we have a we're sorting my list, and my list is a list of lists. And so here we're taking the key, which is this. It's this. The key is going to be the max of the element. And so the max of this element is 25. The max of this element is 35, and the max of this element is 15. So it's first going to be 15, and then it's going to be this 25, and then it's going to be this 35. So that's pretty fancy. Oh, there's this reverse thing where you can reverse sort. Reverse equals true. All right, so that's 8.9. 8.10, command line arguments. Well, we kind of do this. Okay, all right. So yeah, you can pass, when you're executing your Python program, you can have arguments which come from the command line. And the way you refer to them is like this. Okay, so it's like print hello, comma, sysarg v0. Let me just copy this here. Copy. Sysarg v0. Or let me do it this way instead. Name equals sysarg v0. And then you can say print name. So I go like this. Test PY Joe Schmo. Oh, no, will that work? Do I have to put commas? Okay, just Joe. How about that? Oh, I gotta include something at the top. Oh, import sys. That's what I'm gonna do at the top. Import sys. Okay, whatever. Joe. Oh, arg0 is the name of the program, so it's arg1 I gotta do. arg1, argv1. I think. Yes, hello, Joe. So this is argv0 and this is argv1. No, you don't need import sys for any of these labs. You're right, that's a good point. I did all the labs. No, you don't need that. I don't think. Quite sure. All right. So this. Oh, I see. So if you want, okay. So you want to do this. See if you go like, if I were to do this, hello Joe Schmo. It just says hello Joe. I have to go. Hello Joe Schmo. I think. Ah, yes. Okay. Cute. All right. Great. Oh, engineering examples. Okay. Well, at 403. Well, let's take a look at these engineering examples here. Where are we here? Oh, here we're just here. Okay. All right. We'll zip through this. See what's here. Because we need to get into dictionaries. Okay, this is calculate the voltage drops across a series of resistors. Well, this is good for electrical engineers. Is there a picture? Voltage supplied, ohms, resistors, so it's divided evenly across that. Did they give you the formula? Voltage equals current times resistance. This is electrical engineering stuff. Matrix multiplication. Yeah, this is interesting if you're going to do matrix multiplication. This is electrical engineering stuff also. Okay, anyway, let's go to dictionaries. Okay, dictionaries. So with the dictionary, it's like there's a key and then a value. Okay, so when you're indexing, it's key value. So if this were just a list, this would be 0 and this would be 1. Okay, sort of. With the list, there's an order, and it's the index. With a dictionary, there's no order, and you have to know the name of you have to know the key to be able to access the value. If you have a dictionary and you don't know any of the keys, you can't access anything. You can't. You can loop. You can do for key in the dictionary and then reference them that way. So you can get at all the keys. But if you want to reference a particular value, like if you have a dictionary where Bobby is this number and Johnny is this number, and you want to reference the key value for a number, that's hard to do. You can reference the phone number of Johnny, that's easy to do. But referencing the key value for this phone number, that's hard to do. Okay, so it's kind of like who got an A+. Well, Jose got an A plus, but to find out that it was Jose that got the A plus or anybody else, you would have to loop through all of them and check each one of them to see if it's an A plus or not. Whereas if you just want to find out what Jose did, you just say, you just ask for the value of that dictionary where the key is equal to Jose. So here, for example, Jose's grade is my dictionary, and this is the key value. See, so it's my dictionary and then the key value. And if you want to assign a value to a key value, you just do this. You say the dictionary, and then you say, instead of an index, instead of a 0, 1, 2, 3, 4, it's the key, and this assigns the value. And the way this works is if my dictionary did not have an entry for Jose, then it creates one. If my dictionary had a value for Jose, if Jose was already in there, then this is going to overwrite what the value of Jose was. And if you want to delete something from the dictionary, you use this keyword, the delete keyword, and then you say this is going to delete Jose from your dictionary. And you can do this. If Jose is in my dictionary, you can test for the existence of a key value. You can't test for the existence of a grade, of a value, but you can test for, I don't think, you can test for existence of a key though. What does this do? Complete the program that implements the grade book. Student grades in the dictionary should consist of entries whose keys are student names and whose values are student scores. Okay, so we're starting out with a empty dictionary of student grades, and this is where we ask, and then we're going to keep on grade prompt. Enter the name of a grade. Add or modify student. I see. Okay, so okay, got it. All right. So we're supposed to write this program. Pre-enter any input for the program, then press run. Okay, so this is just gonna do that. That's an assignment statement. It's an assignment statement that doesn't do anything. Well, true. It's gonna ask for. It's gonna ask for the menu prompt. So it's gonna it's asking for a 1, 2, or 3, or 4. And so I'm gonna say 1. And so here, okay, so here's, oh great, okay, yeah, you can do it this way. Okay, so you don't need to read it in and then, well, you kind of, okay, so this asks for an input, and you're supposed to type in a name followed by a space, because we're going to split on a space, followed by the grade. And then we're going to split that into a name and a grade, and then we got to, okay, so once we have the name and the grade, then we can say student grades of name is equal to grade. Okay, so that enters something. And then, so number 2 is supposed to delete, so that can be delete student grade. So I guess you want to delete a student. So we got to input a name. Name equals input I don't know if I'm doing this right. All right, so that does that. What does 3 do? Print student grades. Okay. What happens if I just do print student? I'm just going to do that. And 4 is quit break. Okay, so I'm going to say, first thing I'm going to do 1. Then I'm going to say Joe space A plus. I'm just going to say, hey, Mary A, Josh B. And then I'm going to say 3. Wait, will that work? No, I need to do 1 Joe A, 1, 1. Let's see what this does. Oh, maybe I have to, do I have to end it or something? 4? Do I have to end it? Oh, okay, it looks like it worked. So, prints out my menu, then I enter the 1, and then so looks terrible. Okay, anyway, here I entered a 3, I guess, and I printed out the grades. Then I quit. Well, anyway, okay, so it looks like it worked. All right, what's this challenge activity? Okay, delete Prussia from country capital. Okay, so what is this? Is this my, oh, is this a solution? Oh, no solution provided. Okay, so it goes in there. Okay, oh, I got it. Yeah, the white area is what you type in. Okay, so what am I supposed to, what's this supposed to do? Delete Prussia from country capital. Sample output with input. Well, this is the input. Okay, so I think this is just a really dumb thing. Okay, so there's user input, and then we split it up it's separated by commas. Okay, there's a comma there and there's a comma there. And so we've got entry. So this is one entry, and this is the second entry. Togo and Lome or whatever is the second entry, and Prussia and Königsberg is the third entry. Spain and Madrid is the first entry. And then I'm supposed to put something here to delete Prussia. And then it's going to ask, is Prussia deleted? And the text tests to see if it is. Spain deleted, test to see if it is. It should say it's not. Well, the answer is delete country capital of Prussia. This is the input. And we want to delete. This is the key. This is the key. Togo is the key, and Spain is the key. And I'm supposed to delete the one where Prussia is the key. So to delete the one where Prussia is the key, it's simply this: delete country capital, not country, Prussia. So I think that's the answer. Kind of dumb. All right, what's next? Airport codes. Cincinnati, Paris is CDG, I guess that's Charles de Gaulle. Cincinnati is CVG, don't know what that is. Tokyo is Narita, I don't know. Okay, and so print that. So what is, it's prints out. Okay, great. What's next? Airport codes is that, and I print Seattle and I print Minneapolis. Oh, SEA, MSP. Nice. Dallas. DAL. Houston. IAH. No. Oh. HOU. Okay, because this overwrites Houston. Nice. While province name is not equal to exit, if province name is in the provincial capitals, in other words, if it's in Alberta, BC, Toronto, or Yukon, then print it. Otherwise, just print an X. Okay, so is this in the provincial capital? Yes, it is. So then I should print it. Edmonton. Is California a provincial capital? No. So it should print an X. Capital X, lowercase x. Is Yukon? Yes, it is. Is exit? I guess I'm done. Yes, okay. Same thing. Oh, first we read the provincial name, and while provincial name is not equal to exit, delete it. Otherwise, print X. Okay, so it's going to print this, copy, paste. Then it's going to print Manitoba, which is Winnipeg, and delete it. It deletes it after it's printed it. And Nebraska is going to print an X. And then Nunavut is it's not in there. Nunavut is not in there anymore because it deleted it. It deleted it. So it's going to be another X. Sorry. 1, 2, 3, 4. 1, 2. Okay, that's it. Is that right? Yeah. All right. Awesome. Dictionary methods. Okay, so update. Oh, okay. Okay, so these are some methods, and so this is the dictionary. If you want to clear out the dictionary, like dictionary looks like this, you want to clear it out, just do this dot clear, and that empties it. Here, we're supposed to get the value, that's the key. If the key's not in there, it's going to give us a default. If the key does not exist, it returns a default. So let's say we got a dictionary, it looks like this. And it asks for Jane, and Jane's in there, so it returns the 42. But then it asks for Chad, and Chad is not in the dictionary, so then it returns the default. And here we're concatenating or merging this dictionary onto this dictionary. So if we have a dictionary like this, and we want to update that dictionary by adding another dictionary, and this is just a single entry dictionary, that's fine. Then it's going to now have three elements in it. And here we're popping off, we're removing, taking out the dictionary with this key value. And if it's not in there, it's going to do the default here. So this thing pops a mod. And so val is now equal to a mod, or the val is now equal to 1. That's what val is equal to. And then when we print out the dictionary, it's just going to print out what's left of the dictionary, which is Jane 42. Okay, here's a nice challenge activity where, let's see, get San Francisco. Okay, fine. Okay, let's try it. Let's try this. So the first one is get Washington. Washington's not in there, so I'm going to do NA. Next, New York is not in there, so I guess it's NA again. And Houston is in there, so I can do IAH. Is that right? I guess it is. Here we're going to get Austin, Austin, Austin. Oh, we're popping it. Okay. So the first time we get Austin, it says AUS. And then the next time we get Austin, it's going to say AUS, but it's going to get rid of it. And so this time it's going to say NA. I believe this is right. Yes, it is. This one is going to say, oh, okay, so we add, okay, so here we display out Atlanta. This one we're going to display out NA because it's not there. And next one we're going to display NA because it's not there. And Washington is IAD is there. And then we're going to add these ones. So now airport codes has more stuff. Does it have an Atlanta? No, it still doesn't have an Atlanta. Does it have a Dallas? Yes, it does. DAL. Does it have a Washington? Yes, it does. IAD. Is this right? Ah, it is right. Okay. All right. So anyway, you can do the next one. Iterating over a dictionary. So here we have a dictionary. This is another way of defining a dictionary. So this is num calories, and the key is going to be called that, and the values is going to be called that. And so this prints them out like that. And here we can, if we want to, for each of the keys in soda. So this prints out the keys. The keys in num calories is Coke, Coke Zero, and Pepsi. The values, we can loop through the values of num calories, and that's going to print out the values. These things. These are the values. Okay. We can convert, use a list to convert view objects into lists. Okay, so we have a dictionary, and if we want to convert here, so here we're making a list of the values in solar distances. So list of distances is going to contain, this is the first one, this is the second one, this is the third one, and this is the fourth one. So I don't know what the order is of distances, because the dictionary doesn't really have any order. But here if we sort, it may have an order, but it's however it was created, however you append on the elements, the records, you can call them. So this sorts them based on, sorts the list of distances. So now it's going to be where this is the, whatever is the smallest one. I guess this is distance from the Earth, must be. This is the farthest away one, e to the 9th, e to the 6th. This is closer than Jupiter. And this is between Venus and Jupiter, I guess. So if we sort them, then then there's an order. There's an order to a list. And this is the, yeah, okay, so this is, the closest one is going to be this. It says e to the 8th. Oh, I know why, because this is, it's this one, because it converts it to where this is a number between between 1 and 10. So there's just going to be one digit to the left of the decimal point. Here there's 3 digits to the left of the decimal point, so it's adjusted. So this goes up by 2, and the decimal point moves over to the left 2. So this is 1.164 E8. 1.164 E8. And this one is 2.197 E8. 2.197 E8. Okay, so that's, all right, so that's how that works. So here we create a list of the values, and then we sort them using this sorted method. Iterating over, okay, so dictionaries, report country population. This is looks like the last challenge activity in here. Okay, let's do this one, and then we can quit for the day. Write a loop that prints each country's population in country loop. So we got this here, and prints this. Okay, so we're going to read in an input, and it's going to look like this. And then we're going to split on the comma. So this is going to be one of them. One's China, one's India, one's the United States, and one's Indonesia. And then it's going to create a dictionary called country population. And it's going to be a dictionary. And we're going to, for each pair in entries, so this is entries, there's 4 entries, this one, this one, this one, and this one. Each entry's got a colon, and each entry's got a left of the colon and right of the colon. And so here we split that pair, and the diction here are the two parts to each element of dictionary. So so it's going to be key and then value. Okay, so we split the pair, and the left-hand side of the colon is the key, and the right-hand side of the colon is the value. So country population is now a dictionary. For example, this is the left-hand side, and this is the right-hand side. It's not up here, but so right here we have to make a thing that prints. Oh, and look, this is indented, so it's a for loop. So I guess it's something like for, and we can say country population. Oh, it's got to be pop. Country pop. For country pop in country pop. Doesn't this work? Does this work? No, I have to put items. Why do I have to? Where is that? Items. Dictionary items method is useful because it produces tuples containing key value pairs. Okay, so I want to produce tuples. I want to produce these tuples. Okay, so I want to produce tuples, right? So fill in the code using this where appropriate. Print each key in dictionary. So this is in my dictionary.keys. Is that right? Yes, okay. And this is negative values. Okay, so value in values. Values. Oh, my dict values. Oh, I use items instead. Oh, because I'm doing key and value. Okay, so that means I use items. This returns the tuple. This is the tuple. Got it. Okay, so that's what it should be. This can be values. All right, so this should be items. Yeah. This. Oh, this has to be this. all still here. Okay. Pop country. For country, comma pop in. Oh, missing the colon. All right, so that's how that works. Okay. Anyway, we can. How far do we get? 8:15. Dictionary nesting. Well, what is dictionary nesting? Dictionaries within dictionaries. Yes, it's a dictionary within a dictionary. Nested dictionaries. Sure. And you refer to them this way. Okay. Yeah. Well, there aren't any labs that talk about nested dictionaries. So basically, it's similar to having lists within lists, and it's like you have rows and columns. And in this case, it's the same thing where you have it's list dictionaries within dictionaries, and you aren't indexing. You don't reference each element by indexing. You reference them by their key values. So anyway, I think that's good for chapter 8, and so I'll finish when this thing's done processing. I'll upload this one, and then after that, I'll upload the other one, and you should have everything you need for chapter 8. And if you have any questions, of course, just let me know. All right.
Have a good holiday.
Thank you. Have a good.
Thank you. Have a good Thanksgiving.
Okay. Take care.